Hello everyone. Today we will be covering about building microservices. I'll be sharing the best way to build a microservice, and we'll be using the latest Java LTS, which is JDK 21 plus, and we will be using tools like Lombok. We will be using tools like Jakarta EE and MicroProfile, and this is slightly different than Spring Boot, but I will show you how it can help you to build microservices which are production ready and they are suitable for cloud native deployments. So I have a repository. I'll be sharing the details about the repository in the comments in the description of this session. So here I have prepared a guide. Here we will be building a e-commerce application. This e-commerce application is called MicroProfile e-commerce application. And this guide contains step-by-step, chapter-by-chapter descriptions of practical code examples, which are using various features of MicroProfile. So there are chapters where we'll be building the REST-based services. We'll be adding persistence and database to the microservices. We will make them configurable, dynamically configurable through various techniques using the environment variables, using the configuration files, and using APIs, so that various options will be covering. We'll be covering about how to write health checks for microservices. We'll be covering how to trace performance matrices, how to make a microservices documentation so that developers can understand and use the APIs in a very effective manner. We'll be covering about authentication, how to implement security into microservices, and then how to make them fault tolerance, and how to build clients, how to consume REST services. So this is what we will be covering, and we'll also be covering building reactive streams, and we'll be covering about how to build GraphQL APIs. So this is what I'm planning to cover. So let's dive into this tutorial. So here we, as I said, will be using latest Jakarta EE10 and MicroProfile 6.1. We will be using even 7.1, and this is our I'll be sharing this document for you. So here we have various chapters which are complete covering various aspects. This I will update and share to you after this session. But here this will be a hands-on session, and we will be coding live, and we will be also using various GitHub tools. For example, we have GitHub code spaces where we will be instantiating a development environment in the cloud, and we will test the microservices. So using the setup of our dev container. We'll also cover Docker and Kubernetes and how they can be used. So this is a very comprehensive session about all the aspects of microservices. So let's get started. So here, the way we should get started is by building so I have a repository, I have a dev container setup. I will also explain this in detail, but what I will do first is to start my code space. So what you can do is I will share the dev container configuration, and you can use this get dev container configuration, or you can use a code space image, which could be a Java image, Node.js image, and then you can keep adding various components. So yeah, you can use a standard Java container and then add more components as you need it. So here I have a separate video about what are dev containers and what are the ways to configure and add components to the dev container. So you can think of dev container is your lightweight container which is very similar to Docker container. You may use Docker containers also as your dev containers, and in this dev containers you have a Visual Studio Code running, so you don't have to install anything on your laptop or your local desktop. Everything is being done on the cloud. And important thing is we have a dev container configuration. So here I'll show you what we are using in this particular dev container. So here let me also make this font bigger so that it is easier for you to understand. So as you can see here, this is my dev container configuration. I have named this dev container MicroProfile tutorial. Hope this is visible. I can also make it a little more bigger so that text is even easier for everyone to understand. So here you see here there is a dev container configuration. So in any GitHub repository, if you create a folder with dev container as the name of the folder, and within that you have to create a file called devcontainer.json. So you see here on the left side, this is the files and folders which you have to create. This is very much required to run any remote environment or a container image, and without installing anything on your local machine you can do development. So here as you see here, I have named, you can name it anything. It's not that important. It is just for documentation purpose. Then you have a base image here. So I've used a base image which is dev containers universal image, and in this I have added various features. I've added here Node. I have added version 20 of Node.js. This you may not need. I am building documentation and documentation site, so that's why I have Node. You may just need a feature which is Java, and as you see here, Java has version 21, and I am also installing Maven, and Maven is 3.9 version. So this is an important component which you should use in your dev container setup because we are building a microservice application. Again, you can skip the Ruby component here because this is again I'm using some scripts to build the documentation site, so that's why I'm using it. You may also skip Python. So what you need here is basically Java dev container. You may also need a Docker container later, which I will show. So this is about dev container setup. So let me just test my live streaming also for a minute. So hope till now everything is clear. So let me go to my YouTube channel and see how is our live stream coming up. Is my audio available? Is my screen properly shared? So all these things I am just testing. So just wait for a minute. Till now everything is clear. So let me. Awesome. So I see we have this particular stream going live. Let me also log into the chat so that people who want to interact, they can send a message, and I can also view their chat messages and reply if something is not clear to our viewers. So this is about the code space. You see here, I have in a browser a code space running. Basically, it's a container and it has a Visual Studio Code running within it. So nothing is required to be set up locally. And I have the base image. So let me ping you this base image. details about it also in the chat. Uh, Let me see. I should be signed in to chat. Perfect. Yes. So what is very important in the first stage? You need GitHub code spaces. Okay. This is the step one. You have the base image, which is this is the base image. So this is important. This is a universal base image. And then we have a feature, which is so if you are watching with me, you can also try this. You can start instantiating a GitHub code spaces. So to instantiate a GitHub code space, you have to go to the GitHub dashboard, and on the left side you will see the code spaces option in the dashboard. So now once you run this code space, you will see this is my code space. This code space is I have also synced this code space with the code repository. So I'll share the code repository so you can try out exactly the same image. Now, next step is you can do customizations. For example, you can, as I said, there is a Visual Studio Code instance which is running in this dev container, and there can be multiple extensions which you can pre-configure. So here, something which is important is VS Code Java Pack. So these are the extensions which you should use. You won't need everything because I use ASCII Doctor for documentation purpose. So this is no preview and ASCII Doctor editor, but which you may not need. You would need GitHub Copilot. Again, GitHub Copilot is a tool where you can chat with the code, and it can generate code based on the context of your project. So if you are adding some comments, it will try to understand what you are doing, and it will share you code snippets which might be useful. So it's like an autocomplete, but maybe you can think of autocompletion on steroids. It in the background uses a LLM, and it can generate the code, it can review your code, it can explain the code. So that we will cover. So this is a good extension, GitHub Copilot. You can use this. I would recommend you should use it and get familiar with it. There is Java extension pack and Maven. So these are the Java related extensions which you would need. And then in addition, as I said, I will be using a framework which is based on Java, similar to Spring Boot. But yes, it's more modern and lightweight and specifically designed for microservices. So this is MicroProfile. So there is an extension for MicroProfile, and I would be using OpenLiberty server for development. And why OpenLiberty server? I will explain. I will share an article why I am using OpenLiberty server. So these are the extensions which we will be using, and you would require it. So I'm just putting this all information in the chat message for you to make a note and also try it with me in parallel. So a little bit chat message is bigger, so I'm putting it one by one so that you know that easy for everyone to check and also understand what are the extensions which have been used in my code space. And then this is the final. So this is our development environment is ready for building microservices. Correct? So that's what you need as of now. Maybe after instantiating, you can run some commands and you can expose some ports. All these details are not at the moment necessary, but this is our dev container configuration. So dot dev container is the name of the folder, and dev container dot JSON is the file. So now you understand GitHub code space and the concept of dev container. So now let me go to the next steps, what we have to do. So I'll come back to my repository, and in this, I will again open our developers guide. So I am updating this developer guide and keeping it for you. So here, as you see, we have JDK installed, Maven installed, Git installed. You can use SDK Man. SDK Man is a very nice tool for having the Java installed on your system. Again, I'll share about the article on SDK Man so that you can easily install SDK Man, and this can be useful for managing multiple JDKs in your machine if you have to test some legacy application, and also at the same time use another Java version for building some latest microservices. This is a very handy tool for switching between different JDK versions in your development environment. So this all will be demonstrated through an article. I'll share that for you after this session so that you can refer it. So, but I will put these instructions like install SDK man, and it can then pull in a lot of development tools including Java, JDK, Maven. So it makes installation very easy. You can think of it's like an NPM for Java or for many other languages, not just Java. You may use a IDE. IDE is what we will be using is Visual Studio Code, but you can also use IntelliJ Enterprise Edition if you have it. It's a paid product, or you can use Eclipse IDE for enterprise Java and web development. And we will be using a server which is OpenLiberty server. Next is you can clone the repo, so that definitely I will be covering it slowly, so you will understand the code, and then we will be building a e-commerce application which will be demonstrating all the features of microservices. So these are some of the commands for building and running the code, and which we'll be talking in few minutes, and then we will write test cases. So we have first is the chapter 2. Chapter 2 is about getting started. So let's look into the code of chapter 2, what it contains. This is the first code example which we will be using, and here we will be building a basic REST service, microservice, using JAX-RS. Now it is known as Jakarta RESTful Web Service, and we will be using some of the components like JSON processing, JSON binding, and we will be running OpenLiberty server, and we will have an endpoint which is listed here. So let's go into the code and run our chapter 2. I'll be covering the code in very detailed manner, so you can code with me. So the first step what you have to do is you have to create a Java project. In Java project, I would prefer you create a Java Maven project. We also need Maven for building the project. So here is our code. Let me open this. So we have a project. The project is named as MP MicroProfile e-commerce store. And within this, we have SRC folder, and we have within SRC folder our main folder where we have the Java code. At the root level of the project, we have the pom.xml, which contains the Maven project. So let's show you what is there in this project. So again, as you see that we will be using Maven. If you want, you may use Gradle as well. But yes, for demonstration purpose, I have used Maven. So you see here the root element of the Maven. These are the details. This is common stuff which is there in all the projects. Then I have given a group ID. I have given the name of the artifact which we will be generating, and we will be packaging using var. So web archive is our packaging type. So this is our Maven configuration. Let me put this for your reference and easy understanding. Now next thing is we have some properties. You can just go through all these properties. So we have UTF-8, encoding, outcoding. Then what's the Maven version, Open Liberty Maven version, which we will be using. There's an Open Liberty plugin in Maven, which we will be consuming, and 3.10.1. So properties basically your variables or the properties which you will be using somewhere else. It defines various properties, and then we have liberty configuration. So some of the port which we'll be using, so we can ignore this, but what is important here is the dependencies. So one important dependency which we'll be using is Lombok, which is for auto generating the boilerplate code. Then we have Jakarta platform, Jakarta E10, and we have MicroProfile 7.1. These are the two components which we are using for running microservices code. Then we have MicroProfile dependency and Jupyter JUnit test runner. So for writing unit test, JUnit tests. So Jupyter engine, this is the test runner, and for writing test, we have the Jupyter library. So a scope is here test. So this is these are the dependencies which will be used for test. And provided means this is provided by the runtime. So we are using Open Liberty server, and this dependencies will be provided by the runtime. So this is various configuration. So here we have compiler, we have the release here, and we have you see here different configurations and Maven plugins, and we have enabled this in Liberty Maven plugin, and we have these are the plugins which are being used for building our projects. There is a Surefire plugin for running the tests. We'll see this. So failsafe plugin for running functional test. So these all are well documented in this source code. I will share the source code for pom.xml. So basically the first step is you should have a pom.xml, which is your project build configuration. It should be defined well. Now let me demonstrate how to build this particular project. So I will be coming to so first thing is we have to go to the folder where we want to build. So let me first clear I am into my workspace, then I should go to the folder code. Then chapter 02 is my folder where I have the project, and the project is mp epom store. So I'm inside the project, and in this particular folder, root folder, I should have the pom.xml file. Now if there is a pom.xml, then I am ready to build the project. And to build this project, what we have, I have already documented the command which we have to give to build this particular project is mvn clean package. So this is what is the command to build any microservice, and it will compile the Java source code, it will run unit tests and package the application as the var file. So same I will do here, mvn clean package. Okay, so there was a typo. Let me run this command again. Clean package. Okay. Now it's building, it's compiling the Java source code. mvn. Let me put this command. So you see, build is successful. Now there is no failures. There is a unit test which is run. So this is there. Now let me look into the source code also. What is there? So in this source code, we have a REST service. Now to build a REST service, we will need an entity. Entity is a Java object. And in this particular entity, we have the resource which is defined. So here you see I have a product. Product is the entity for which I will be defining a microservice which can perform CRUD operations: create, update, read, update, delete operation on the product object. So here we have an ID. ID is the identifier for the product ID. We have the name of the product, we have the description of the product and price. So it's a very simple entity, and we have setters and getters for it. I have not written it because I'm using data as my annotation from Lombok, and this will generate getters and setters. And we also have all argument constructors. So instead of defining all argument constructor, it would be like very tedious. I should have written a product method with the same name as the class and with all the parameters, long ID, then string name, string description, string, and double price. So it should have the entire signature, and then I will be setting all these attributes or members of this attributes of this class. So it would have 5-6 lines of code. But yes, if I give this annotation, it will be auto-generated by Lombok library. So these are entity. Now we have a resource. Resource takes care of REST related details. So here in the resource, we have path. We define the path as the products, and then we have this particular resource which is application scoped. So this is till the entire application is running, this entity or the bean component will be available. And we have a list of product here, and it is initialized with some values. So I have two products defined. One is ID1, have the name iPhone, description Apple iPhone 15, and price 99,999. So this is what no, I have initialized the list of product. Then I have a getter method, and which will return JSON. So this is how I will annotate. And so it's so simple, straightforward. It returns a list of product, and I'm just returning the products. So this is my resource. So in the resource file, I will be taking care of all the HTTP request handling. So everything which is related to REST standards, REST protocol is being taken care in the resource object. And resource object is using product entity. Now we have a REST application also defined. In the application, we have the path API and nothing is there. We can put some configurations, but right now there's no configuration required. Everything is default. And this is my product REST service. So this is just the code which is required for running product code service. I have already covered pom.xml. That was one of the build configuration file. And this is our entity class, the resource class, and the REST application class. These are the three classes which we have defined. Now we are running it in Liberty server, Open Liberty server, which is an open source application server. And this is a very flexible application server. And here we have some configuration. In this, we have told that there are some features which we need. We need platform MicroProfile 7.1, platform Jakarta 10.0, and then features which we'll be using is RESTful web service and JSON binding. So it's a very customizable application server. We can add and remove component, and it becomes very lightweight because many features which you will not be using in your application, you may not add it to the server. So this is very nice application server because you will have a very small footprint, which is very important for scalability purpose in cloud server. So this server is built for cloud native development, and this is very lightweight, and you don't have to manually install the server. It can be installed by Maven. The required dependencies will be installed by Maven during the build time. And there is some configuration about the port, which it's reading from the properties files of the pom.xml. So now let's run this project. So the command to run this particular project is, we have ambient liberty run. This is the command. Liberty is the plugin for Maven, and Maven is the command, and then there is run option which will run this particular application. So now we see some errors. Failed to execute goal on project. Platform could not determine the following version latch feature cannot be installed. There might be some typo in this. So let me see. So here, now let me demonstrate the use of Copilot. So as I have the Copilot plugin installed in my Visual Studio, I can ask Copilot to fix this. So here, I'll just say that this is the error I'm getting. It will come up with some recommendations about how it could be fixed. So I think the Open Liberty version which we are using is an older version, and that could not be understanding this feature platform. So I have faced this previously. Let me see and fix this. Okay. So here there is an explanation. The error occurs because you have two platform elements defined in the feature manager. Liberty doesn't support multiple platform specifications. So this MicroProfile 7.1 already includes Jakarta EE10. You only need one platform declaration. And then it's saying that, okay, I will remove this particular declaration. Let me allow it to allow always. So it will remove this duplicate platform feature. Now let's see what happens now. So now coming back to my server configuration. So this will say keep it. I removed it. And now let me run this again to see if the build passes this time. Okay, so this is actually the wrong fix which it has provided. So let me try again. We'll go through and look into it. So I see that no, this is, I will undo this. I will even put here the platform. See, it's also doing auto completion. So this is how I have this ready. Now I have the server here, and then I have the pom.xml. In the pom.xml, we have here so I would also like to remove this source compiling because we have the release already mentioned. Let me look into the README file. So here in the README file, okay, let's see what's the Java version. So we are running this command Java version. So could not create Java virtual machine. Sorry, Java version. So we have the Java 21 already there. So as you see, this is, we already have it. We have the project structure. Now let me try fixing this error. Let's use maybe this error. So there's another command which is liberty dev. This is running this in dev mode. So let me give this error. It's perfect. So removing the Jakarta E and separate features resolve this error. Now we have the application running. This is the debug port, so we don't need to open it. We have the port which is defined HTTP port. We have defined this in pom.xml. I think within the properties. So 5050 is the port. We go to 5050 port. We can open this in the browser. And as you see here, we have the context root path defined as API. So here, this is our let's see in the terminal. Source compilation was successful. Test completion was right. So here we have this server is ready to run a smarter planet server configured. So it says it's not installed to use any feature, which is wrong. So here, let me fix this. Let me try resolving this. This is to be resolved. So let me give me a minute. So here we are going to MicroProfile tutorial. So let me come and refer quickly and get back to you about what's the right POM configuration to be used. So this looks good. Now let me look into server feature manager. So they have used like this. So just for time being, let me use this. So instead of platform, I'm just using this. So now we are running in the dev mode. So automatically the changes are synced without restarting the application server. So that's the difference between the dev mode and run mode. So when we run a Liberty server in normal run mode, it just runs, and anytime you do configuration changes or code updates, you have to stop the server, redeploy, and restart the server. Whereas in dev mode, you have the debugging enabled, and as you change your code, the changes are reflected. It could be code changes or configuration changes. It gets reflected immediately. Now let me refresh this page. So you see here our REST API is working. It is returning the list of the products which we have. So it was a very simple REST service. Here we were just getting all the list of products, and these products were stored in the list in the memory, not in the database. The home page. So this is the Open Liberty start page, and yes, so you see here this is Jakarta E compatible, as well as it supports MicroProfile. So this is our first very basic REST service which we built now. So okay, let me give a try, because MP 7.1 is what it's saying. So here we can see the list of features. I will share this URL also so that we can configure the features. So here we have okay. So the problem was in the current installation, the Liberty server was not supporting 7.1. We should have used a higher version of Liberty, Open Liberty. So to use the higher version, okay, let me share one more URL. This is the URL where we have the list of Open Liberty features. So let me come and put this in the chat message for everyone. So here is the list of Open Liberty features. So this is in this particular URL. And now to use the latest version, so I will also show Open Liberty start page. So like we have Spring Starter application, we have Open Liberty Starter application as well, which can generate the project. So this is Open Liberty Start starter application. Okay, so now let me show you this particular application. So here you see we have used, and we have only 7.0 available. So that's the problem. Why this was not building. So now let me fix this by changing it to micro profile 7. And in the feature list, we see that this is 7.0, which is available. Okay. Now, if I do this, it will automatically update. And now we don't need, let's come back. So let me quit this and let me start it again, just to see that if everything is working as expected. Okay, so now let me come back to our starter application. Give me a minute. So now if I go to my starter application, I will again take this URL from our chat. So I have the starter application. We have up to 7.0. We will generate the project. Okay, Liberty Maven plugin 3.12.2. This is what is being required. Zero. This is what I am updating. Yeah, so updating the Maven version helped it. Correct. So it should be 3.12.0. Correct. Now you see here REST API should work. Correct. So I like this way of specifying the features, where we have the server.xml. We just define the version at the root level, and we don't have to define the versions for the component level or at the feature level, right? So the only thing is to have MicroProfile 7.0. We need the latest plugin. So let me try this with the 7.1. So this is not a valid because is what is being supported by OpenLiberty as of now. So this completes our first example, which is building a simple REST application. But this REST application is very basic. We'll move to next chapter where we will be adding more features to this particular REST application. So let's look further. So we have this development mode. So we see that this particular application is available. Now let's look into chapter 3. So let's come to chapter 3 code. In chapter 3, we have a catalog service. And in this particular catalog service, let's see what it does. So here we have some persistence now getting into play. So here REST resource, we have the resource folder, which provides the HTTP endpoints. We have the service, which implements business logic and transaction management. We have repository, we have entity. So these are the 4 components which we have. We have the database configuration. We have the Derby database, right? So this is what we will be doing in our new example, but let's look into our in-memory example. So here we might have added more. So our REST applications there, we have some initialization. Okay, so this is about, we have defined an interceptor for intercepting and logging each of the calls. So let's look into this. This is another nice example which we should understand. And this is basically about Jakarta EE. I'll quickly go through it. So we'll first look into e-commerce example where we will be implementing an interceptor. Interceptor is nothing but a method which will be called every time a REST API is called. And how do we do that? So here in our, let me close all my files so that we can start from fresh. So here in our product, we have an entity class. Entity class has no argument constructor as well as all argument constructors. So this is important here. So these 3 tags are important here. Then we have a resource. In resource, we have a logger which is defined. We will be injecting product service. Product service is the service where we have all the business logic defined. We have a get method which will get all products and it will return a response object. So this is our get method. We have a get method to return an individual product as well. And we have a post method. So we have implemented here all the CRUD operations. We have the put for update and we have delete for deletion. Let's look into the service class. Service class is the class where we will be initializing product list of products. We are adding some logging also. So here we have defined the CRUD operations. We have the REST API. So we have the logger. We have input stream where we will be loading the log configuration. And we have here input stream and then we have the logging. So basically this particular method is initializing the logger. But then we have an interceptor. So we have interceptor binding. We have defined another annotation which is logged, and we have a logging interface, logging interceptor. So log method call, it will log for each of the methods when the method call has been entered, when it is exiting, and if there is any exception, that will also be logged. So we don't have to put these entire log messages within all the methods. Instead, we can just use the logging interceptor. Okay. So now let me also show you a feature. So if you are unaware about what does this code is doing, you can just say explain. And now it's explained. So this is helpful for learning about what a code does. So now you see here the details about. So the code line, this is a package declaration. Okay. Because, okay, this was highlighted. So we can just say ask. We'll explain the entire code. So this is another very good feature about Copilot, that you can highlight some code and it will explain. So it defines the CDI bean for logging demo service, which serves as a practical demonstration of how method interception work in MicroProfile environment and Java Jakarta EE. So the class is marked as application scoped, meaning that a single instance of this service is created once for the entire application life cycle and shared wherever it's needed. Okay. So you can use this annotation at the class level as well as the method level. Now let's look into where this annotation is being used in public in the product service. So if I go to the product service, you see this is being used at the class level. So all the methods will have this logging for entry, exit. You may also have some logging within these methods where you are going into any business logic. You can update that in the logs about the business logging, business logic, but generic entry and exit of the method, some generic logging is done in the interceptor. Now let me run this particular code So now I'm moving to another chapter. So let me go to cd dot dot cd again, cd chapter 03 and cd mp e-commerce and mp e-commerce store. And then here we should have at the root level our form configuration. So mvn clean package, this is the command which will compile, it will run all the tests. So the Java compilation is successful, tests are successful. And then we have to run mvn liberty run. So I'm running the Liberty server. So now if I look into the feature definition for this particular server, we have 7.1, 10.0 defined here, and the rest is okay. So now log messages are coming here. Let me call the service. So this is get all products. So this is giving me the list of all the products. And now if you look into the logs, this is the logging which has happened. There is an info log. So it's about fetching all products. It is about entering method and exiting method. Okay. So everything is being logged here. Entry, exit. What was the response? Now I have the other methods which is getting by product ID. So here again we should have seen some logs that entering method get product by ID. This is the ID. I can give another product ID. So same, now this is also logged. So this is how the interceptor works. Any method which you want to execute, you can put some interceptor so that you can enable logging. Now next thing is let's look into this file server.configuration here. Not much change except we have the context and dependency injection module available. And there is the logging properties also, so which can help you to kind of provide what is the logging level. And we are logging in the console right now, so we have this particular handler. We have the formatter also for log messages. So you can, for every package, configure this, and these configuration changes will be picked up in the runtime, and you don't have to restart your server for changing any configuration which is related to the logs. So this is the definition of this is the demonstration of interceptor. So let me take a small break. I'll be back in few minutes. I'm back. Now we'll look into how to implement a microservice using Derby database. So we'll be hooking the database into our existing microservice, which is the product microservice. So as you see here, we have in this particular folder catalog project. So let me stop my Liberty server. Now we'll look into the source code. So here we have the configuration, and we have the artifact ID catalog. We are packaging as var, as in the previous examples. We are using the same port 5050. And here we have with the dependencies, which is Lombok, Jakarta EE, MicroProfile, JUnit, Jupyter, and we are using some other dependencies, REST easy. This is for testing microservices. And yes, this is an interesting project because people who want to use mocks, they can use this example, and this demonstrates how we can test a REST service. And we're using Java 21. Yeah, Liberty, we can update this also to 12.0. And we have here the Liberty. Apache Derby is a Java-based database, and it can run within our application server. So this is provided by OpenLiberty. So let's run this particular project. But before that, let's look into the code. So here we have an entity class. Entity class is now annotated with the entity because this is mapped to a database table. So these are the these are the annotations. So table name equal to products. This specifies that the entity will be stored in the table name products. Then we have the two queries. One is find all, and which is mapped to a SQL query select P from products. And then we have find by ID. So this is query mapping. Now we have an ID. We have a generated value. Strategy is generation type equal to identity. Column name equal to ID. So this is defining the ID. Again, for detailed discussion about what are the various generation types, what are the different strategies which we can use to auto-generate IDs, I'll share an article. So there are different kinds of database, for example, Postgres, MySQL, and they support different kinds of generation type. So that discussion we can do through an article. So I see one person saying hi. So hi, I'll just reply. I just got signed out from the chat. I'll sign in again in a minute. Great. So this is about how do you do mapping, and then we will proceed. We will have this string name. So here you have some validations as well. So minimum, maximum. So in Jakarta E and MicroProfile, the validation is very simple. It's using annotations. So for all the attributes, now we have the column defined. So column mapping, this is ORM, object relational mapping. And then we have also validation, which is the maximum size should be 500 for description. So these are validations and validation messages as well. So in case any queries, feel free to post in the chat. I will be happy to reply. Now we have the constructor, we have getters and setters as well. So this is how we define the entity product. So we have taken the same POJO for product entity, and we have updated it with annotations for ID generation, column mapping, table mapping, and queries. Now, next thing is our repository. So repository is the class which will be, so we'll look into the repository. We have one repository interface which will define all the methods like find all products, find product by ID, then you have create product, update product, delete product, and search products. So various methods have been defined here as a product repository interface. And we have two implementations of this repository. One is the product in memory repository, and then JPA repository. So using the same repository code, so here let me open the interface in memory. In memory is an annotation which we have defined. So this annotation is CDI qualifier, and there is a retention policy which is at runtime. The target element, this annotation could be applied to a field, method, or to a type, which could be class, and could be a method, could be applied at the method parameters. This is what is how the qualifier is defined. And similarly, we have a JPA qualifier which is defined. Now the advantage of this particular qualifier is that this could be applied to any class. For example, here product in memory repository. So when I apply this qualifier, this will indicate, or this will make this class work with in memory data. So now here we have a hash map which is for storing the list of products, and now we have used concurrent hash map. Earlier we have used list. The problem with the list is if you have to find out an ID, if it is being used in linked list, then it will be taking more time to find out the ID. With hash map, you can find products very quickly. And we use concurrent hash map because there could be multiple queries which could come to identify or to find a product ID. So we have to make it thread safe. So this is our implementation for the class where we will be updating in memory hash map. And at the same time, we have another implementation where we have JPA annotation, and we have this defined as a database entity. So this is about repository, but actual database operation will happen in the service. So service class has our business logic. So you see here, find all products, find product by ID. And we have update product. So all these methods are defined here. So it's calling repository methods. And here we are injecting the repository, appropriate repository. So here we are injecting the JPA repository. If we have to inject the in-memory, so the same implementation will work only by just changing this annotation to in-memory. We'll have the same repository class working with in-memory concurrent hash map instead of Derby database. So this is a very convenient way of implementing your repository. So if anytime you are building a microservice where first you are using in-memory storage and then you want to switch, you can implement this way so that it could be very flexible. We have a resource class. Resource class has various HTTP methods defined. So here, this is our resource class. So now let's run this. But before that, we went through the pom.xml. We also will go through the server.xml configuration. So here we have MicroProfile 7.1. We have Jakarta E10. We are using JAX-RS or RESTful web service. We are using JSON parse processing, JSON binding, CDI, persistence, and JDBC. So these are the features which are being used. So as you see that as we are enhancing our microservice, we are adding more and more features to our server. So now let me run this. So I have stopped the server. Let me start again. Now let me go to the other project folder, which is called catalog. And within this, we will have the pom.xml. We can now run, first compile and package the application by ambient clean package command. So this will compile and package our application. So compilation is successful. Now this is packaged. Now we have to run this. So I'll say ambient liberty run. So this should instantiate, it should create the database tables as well. And it should return the data from the database. So now I will go to my application server. Here the context root is catalog. Now from the database. So you see here we have got the list of products. Now we have more products because we are storing the data in the database. With database, if we restart the server, the data is not lost. So if I query for a particular ID, for example, 4, it will return the product with ID 4. Again, this is returned based on the database query. So this is database this is our microservice which is working with a database. Now coming up with tests, we have written some test cases as well. so that we can verify this. So there are various ways to test our microservice. One is we have defined mocks, and then we can test our microservice. So we know these are the data which we will be updating, and then we will try to retrieve this, and this is the test, whether our RESTful service is running as expected or not. So in Visual Studio Code, you can run tests using the test plugin or by running the Maven command. So let me give you the Maven command to run the tests. We can say here help or help let me quit. So we may not be in the dev mode, we may be in the run mode. So now let me come out of it. So yeah, we have unit tests which are written and which could be run, and details of how to run the unit tests will be provided in this particular README file. And now coming back here, so here we have this is the project structure. This is layered architecture. So we have built this microservice using layered architecture. So you should note here that we have a resource class, then we have the service class. These classes or components, they are put in respective folders. And then we have the repository and the entity. Entity is your domain model, and this will have the mapping to the tables and columns. Also, you will have the named queries. So this way you have everything which is related to domain modeled in the entity class. Then we have the repository class. Repository class will deal with accessing object from the database, and this will take care of the database operations. The same architecture is being used in Spring Boot as well. And then we have the service class. Service class has the business logic. You may have the transaction management as well. Wherever there is any update or deletion operation, so any modification to any entity, you should always put this within a transaction, so that there is atomicity of transaction, which is guaranteed. So asset compliance will be achieved if you use transaction as the annotation to the particular method which is updating the database tables. So this is very important best practice you should take care of. I have also written an article I'll share about how to use transaction effectively. Then we have the database configuration. Data configuration, which we covered earlier. We have the server configuration. This is also what we have covered. And then we have this command for running the server in the dev mode. We have this command ambient clean package to build and package our application. Now running the tests. For running the test, for unit test, running the unit test, you can run the command ambient test. And this will run all the unit tests and it will give you the result. So here you see there are unit tests which were run. Now there is a deployment, so ambient liberty run API endpoints. So these are the endpoints which were there for this particular microservice. We have the products. We have product with ID to get a product for particular ID. We have this endpoint for creating a product. So these are various endpoints. This is for update and this is for delete. You can run curl commands to see the request and response. And here we have given the JSON for response and request. So now there is database, initial loading, all these things are mentioned here. Let's look into the database configuration. Here, this will give us important information. So let's look now. This is all we have in the README file. So now let's look into database configuration. So here we have catalog file, and then configuration. So here our database configuration was done within pom.xml. And here is the Derby tools. So these are the dependencies which were used. So yes, there's nothing much in the configuration for just the dependencies and their versions, appropriate versions. So ensure based on your JDK version, the version of Derby which is supported will change. So if you are using something like JDK 17 or even earlier JDK 15, then you may not be able to use this latest version. You might have to use a previous version. So read the documentation of Derby database for details about what Derby version will be used. So this is Apache Derby database homepage. So I will just post this link in the chat again, and this is what we have. This the I have posted about Derby database URL for Derby database, and you will find out what versions will be supported for each of the JDKs here. You have the quick start. I have a detailed video about how to use Derby database. So here you can see these are the versions which are supported. Right, so as per your JDK version. Now in server.xml, we have some Derby configuration. So we have the JDBC driver, which is being defined here. And we have a script for creating database here. So that means every time you create a database, so this is an embedded database. Embedded database means the database which is embedded inside the application server. In production application, you don't have a database embedded in your application server. You will have a dedicated database, which may be remote as well to the application server. But this is for development purpose, and that's fine to have a database which is embedded. So now we have seen how we can build a microservice which can interact with the database. We have also learned about the interceptors. We have learned about how to componentize our REST application into various components. So we have the entity class, then we have the service class, and then we have repository, we have the resource class. So these are various components of a REST service. Now let's look into next topic, which is configuration. We should also make our RESTful web service configurable. So the next chapter we are talking about how to make a application, how to make a microservice configurable. So let's again look into the basics. So configurability is important because your microservice will be running in different environments. You may have a test environment, you may have a production environment, and in test environment you might need a Derby database, but in production you might need Postgres or MySQL, some scalable database. So all that configuration could be achieved using configurability. And even before that, I will also focus on something which is called OpenAPI or Swagger. So let's, yeah, this will be more relevant. Let's document our microservice, make it Swagger compliant so that it could be easily tested. Because currently, if we have to test our microservice, we should write curl command. So I have here the script, what you should execute to run these applications, because I have demonstrated calling the get methods through the browser. But in browser, you cannot call your put methods or create methods. So there are various approaches which you can do. One approach is you may create a test web application, and in that web application you may have methods to or you may have buttons, and you may have a forms through which you can interact and call the APIs of RESTful microservice. So that's one approach. So here, as you see here, I have a web app defined, I have an index page, and I have the web index page defined. So in order to call all the APIs of product, I may run this web page. So let me demonstrate that. So let's see if our server is running. So our server may not be running right now. So let's run this one more time, because now the page is not working. So let me run this in MVN by giving MVM liberty run command, so that this web page will be running now. Right, now let me refresh this page to see that the web page is up. So yeah, you see here I have created a web page which will describe product catalog service, some basic details, and then various endpoints, and then there are links for how to call these endpoints. All these details I've provided here. I've provided here the curl commands. You may have the form also. So this is one way of testing. So you may run these curl commands or you may create a Swagger API. So the Swagger API, which we will be talking about, we'll be doing it in the next chapter. But yes, here we have various endpoints which is defined. We should have created a form which could have called all these APIs, but right now that's not there here. But yeah, a similar web page you can create, and you can create forms and buttons to call various REST APIs. But yes, in coming chapters, we'll be doing that. We will be putting health checks so that you can check whether the service is running. We will also put configuration. So all that we'll be covering in next few minutes. So now let's move to this script. This script calls all the methods of the API. So now it has all the curl commands. So here I have defined the base URL, which is our URL of our application. And then if I run this, so one way to run this is first run your server, then open another terminal. In this new terminal, again, we have to go to code, then our chapter and our project. Now we have this file test API in this particular folder, which is the root folder of the project. So you see here we have made some curl call. So first call is get all products. This we have already done with the browser, but same we can do with the command line. And you see the output, which is the JSON of all the products. Now we can run enter and it will run another command. So here get product by ID, and here this is the curl command which is executed in this script, and here is the JSON for that product ID 1. Again, go to the next command. This is creating a new product. This you can't run with the browser because this is a post method, and there are some headers associated with it, and the content which we will be forwarding is the JSON for the product. And when we run it, it creates a product, and the response is 201 created. So this way you can test manually your REST APIs. And then you see here, this is the list of products, but your new product should have been there added in this. So which is Apple iPod Pro ID 9. And if I go here, there should be a product with ID 9. So you see here, this last product is the one which was recently added. So this verifies that our create is working properly. Then we have get new product. So we are getting the new product, which is done. Then we have update existing product. So we are updating product 1, and we may be updating the price. So that is about updating your product, and then finally deleting the product. So the product with ID 3 is deleted. It was earlier present in our product list. The product with ID 3, yeah, this one. It was, price was different. We updated the price, then we deleted this. So now this is not. And if we try to get deleted product, so we will get an error response. So this is the negative test. So 404 not found is the response which we will get when we have this product not available. Right? So we tried retrieving an ID 999, it was not there, so we got. So this way we have run multiple commands using curl in the bash script, and we were able to test the API completely. So this is one way of testing the REST API other than creating a mocks, creating unit tests. With mocks, you can test the internals, basically the business logic of your microservice. But if there is some problem which is external to a microservice, for example, there is a port not accessible, that you cannot verify with unit tests, and this you should verify using the curl command, and curl command will give you good insights about how is your application doing or microservice doing externally. So both these tests are important. Now we will do something similar. This is definitely command line, may not be convenient, and it's not very easily accessible because there's no flexibility. Whatever you give as the command, it will execute it one by one. I'll show you even a better way, which is using OpenAPI or Swagger. This is what we will be doing in the next chapter. So let's move to that. So just give me a minute. I'm navigating to the next chapter. And in this chapter, we will be learning about OpenAPI. So CD chapter 04. Okay, CD dot dot, I have to come to the root level, and then chapter 04. So we'll be building the same product service, but enhancing it to have Swagger or OpenAPI. So we have a catalog service. So now in the catalog service, let me show you the source code. We have the same 4 components. Entity is the same entity, no change. We have the table mapping products, we have the column mappings, we have the validations, so everything is there in this product, so there's no change. The repository is also the same. We have 2 annotations defined, in memory and JPA. We have the repository type which is defined. This is the repository type, and there are 2 types we are available, JPA and in memory. And then we have the repository interface, and then we have a repository which is based on the JPA or database, and another one is on the in memory. So there's no change in the code. There's a resource class which has the HTTP method. There is a service class. Service class has the business logic, and it has the annotation. So for example, here we are using the database, and then we have various methods for creating, updating, deleting of products. Now the interesting thing is, when we implement Swagger, we have to implement it in the resource method. So I'm into the resource method. So here resource method is almost same, except we have few more annotations. So when we say get and produce. This was the annotation which was there previously. Now we have added new annotations, which is describing the REST service. So basically, this is nothing but a documentation. So operation summary list all product. This is the summary of the operation. This is the description of the operation. And you have the API response. So for successful response, you have 200 as the response code. Schema for the response is also there. So this is how you implement Swagger documentation. And we have to do this for all the methods. Different response object we have to document, and these have to be documented in the form of annotations. Same is done for the other method, get product by ID. So at operation, at API responses, these are the two annotations which we have to use. So if we apply all these annotations to all the methods, then that is sufficient to generate a documentation page for the REST API. And this is very convenient and useful. I'll show you in a minute what does this documentation provide to developers, but it helps you in testing, documenting, and sharing your REST API to your other team members so that they can understand, verify, and learn about the service. So let's build this project. Again, the same set of commands, mvn liberty. So first is we have to compile and package. So clean and package. Great. So now this compilation is successful, build is successful. Next we will say mvn liberty. We can run it in dev mode so that if we change any configuration, it is reflected immediately. So now we will, okay, now this error is because we might not have stopped the previous server and we are using the same port. So let me kill this particular service. And here, let me restart this. Okay, now let's go to the port and the web page. Okay, let's see what's the configuration. Then we can come back here. So here we have pom.xml. In the pom.xml, we have catalog is the name of the project, artifact ID, var packaging type, 5050 is the port. So this is what is defined here. And we have a web app. Web app has index.html, and then this web has web XML configuration, so which is we have index.html as a product catalog service. And exception occurred while starting the application. Okay, so some version mismatch is there. which is there in the so let's try fixing this with Copilot. So I'm just sending this message, error message to Copilot, and Copilot will try to find out what is failure all about. Might provide the fix. Let's see. Okay, I'm into the ask mode. So there are different modes. There's agent mode, edit mode, and plan mode. You can go to edit mode also, so that so now if this is the analysis, there's a missing server.xml configuration file. We need to create a server.configuration file, and this is the content of server.configuration file. Server.xml file will be located in, let's see, from other projects. It will be in src and liberty and config and server.xml. So same here, src, then we should have a folder which name liberty, then config, liberty and config within main. So let's create new folder, liberty, config, and within this we should create a file which is server.xml, and in this file we should have this code, and now since we are in the dev mode, yeah, it's saying that dev mode we have to restart it. Let me quit it. Let's close this. Okay, terminal. Let's start a terminal. Let's put it in dev mode. Great, now we don't get any error. And now let's see our Swagger. So first we go to our server. Server is running. This is the Open Liberty homepage. Then we go to our catalog index page. This is a product catalog service web page which we created. Then there is a page for Swagger or OpenAPI, which we can just type OpenAPI/UI. Now we have to configure also Swagger. So let's see the Swagger configuration. So here we have server.xml, and in the server.xml we should have also have the features. And then we should also have a feature for OpenAPI. So again, going to feature list, or we can just say OpenAPI feature is also there now. So now coming back to our OpenAPI Swagger configuration. So let's look into the next chapter, and in the next chapter, I hope we have this relevant configuration which is good for enabling Swagger. So basically, we have this OpenAPI. Let's look into chapter 5 to get a clue of what's missing. In chapter 5, we have configuration also implemented, but for looking into server, MP Open API. This is the name of the feature. So let me fix that. Okay. Let me see what happens next. API. Okay. So now comparing it with next chapter. So we have web app, we have index.html, we have web.xml, we have welcome file which is index.html. So here when we go to catalog, we just go to the root folder, we should get redirected to our welcome file which is index.html, which is fine. Then we have form.xml. Form.xml has all the dependencies. Let's see if there is any dependency which is required for OpenAPI or Swagger, which we are missing. Yeah, this is important because we should have a resource.meta file where we have this configuration, enable OpenAPI scanning, true. So this we have to define within the resources slash meta info. So let me create that folder, which is on the root. Saying resources meta info. Okay, so we have this defined as well. MP OpenAPI scan equal to true. Persistence.xml is also being defined. This is, we have to create a persistence unit, which is catalog persistent unit. There is a load SQL date. So this is for loading the database data. This for creating the script for schema generation. Since we are auto generating using JPI, using annotations, so we don't need this particular create schema.sql. We only need load data, and then this MicroProfile configuration dot properties is already there with mp open API scan equal to true. So let's see why this is not working. So let me see here if I can ask. Let me go in the agent mode, check why OpenAPI documentation is not generated and accessible for the catalog service in chapter 4. So let's see, because by looking into configuration, I couldn't find any problem. So let's ask the Copilot to investigate it. So yes, the Copilot is looking into the server.xml first, as we did. It's also looking into the form.xml. And then we have the server.xml, which is MP OpenAPI API. So looks good. It's looking into the MP microprofile.config.properties file. Okay, there were some conflicting features. So let's see what was suggested. I don't see this is a valid fix. I think the config is missing. We should also have a feature which is mpconfig. nvn clean package. So here don't see MP Open API feature getting initialized here. So let me quit this right now. And then clean package. Then liberty dev. Yes, looking into the logs, I don't see the OpenAPI getting initialized. That's why it's coming blank. Let's revisit this after next few chapters. So now coming back, let's build this microservice further and implement configuration into this. So let me open the chapter 5, which is about catalog service, and we will be adding configurability into this microservice. So here there are multiple ways in which you can configure your application. So here one way to configure your application is by using the configuration file. So that's first way. Other way is you could use environment variable. You can use command line parameters, or you can use the API. So these are different ways of configuring the application. So one configuration which we have already seen is like you define configuration as key value pair. So here we can put some configuration into this service. So here we have product.maintenance mode equal to false. There's a custom configuration. Product.maintenance message equal to some message. So when you add this, this enables the configuration. So let's open this application, and this configuration is injected inside the methods. So here, let's say we have service class. In the service class, we have the repository which is injected. Let's get into the entity class. So entity class is just the domain model of product. We have product repository. Product repository is the hash map which contains the list of products. And then we have resource. So in resource, we have various APIs, HTTP methods for CRUD operations. Here we have injected the configuration property. So it's very simple. You put the configuration property in a property file. So which is done in src liberty config or resources meta inf MicroProfile config file. So here we have maintenance mode equal to false. And then we have in the resource method, the same configuration property injected. And then this is injected to a variable, a member of the class, which is a Boolean type. And with this, when we change the value true and false, it will behave differently. So let's look into what's the value of this particular property file. Let me close other methods. So here this is false. So when the maintenance mode is false, let me build this particular project. So let's quit this. Now cd, I'm going to code folder, then going to chapter 5 folder, then going to my project, which is catalog microservice. Here we will have the POM file. So we can package. So basically compile, build and package this particular microservice. This is successful. And we'll now run this microservice. In this particular application, I see the feature MP OpenAPI is successfully initialized. So here we'll see the Swagger as well. Now catalog is running. So let's first go to Swagger UI, that is working, and it's loading the Swagger UI. So as I shared that there are operations and various API responses parameters which I have added. So it has built a documentation site, and this documentation site is so much useful. You can try out various methods. So for example, I can execute API products to get the list of products, and when I execute, I'll get the products from the database. So you see here all the data is getting returned. Now get we can anyway very easily run in the browser, but we also get the post method. So here we have the post method. We can try it out. There is a sample. I can just say that I want to create a project 17 Pro, and maybe I will put some description. Here I can say Apple iPhone Pro, orange, some color. The price I can put maybe and now when I execute this, I should get the project created. So here's my response. So here the response we are getting (201). This is the response body. Now if we go to the get method and execute this, we should get a list, and here we have this new object which is created, right? So here we can run different methods, whether it's get, post, put. We can update this also. Let me demonstrate this update method also by calling the put. This was ID number 4. So I can just take this and I am into the put method. In the put, I can try it out. I can say here, this is my ID. This is 4. And I want to update the price. Maybe this price is increased to $13.99 and color from gold to gold. So I can update various fields and then I can execute this and should update the product. So this was all about the Swagger. And now let me also run this to see whether these products have been updated. I execute this. And now you see here, this is gold and the price has also been updated. So this is API, which is also generating a Swagger UI. And this Swagger UI is generated from the YAML description. So basically when you annotate your service class or resource class in this case, it generates a YAML which contains the documentation, and then there is a UI which will read this YAML and will create a form which you can use to play around. So this was about the Swagger, or how you can document your API and share this URL with your team. And this way you can very easily test your APIs and it could be used by learning purpose. And when you modify your code, you also should take care that you modify your Swagger documentation as well. And this way you will always have the documentation and your code in sync. Now let's talk about the configuration part. Configuration property was maintenance mode was false. So we were seeing the product information was coming. But if we change this to true, see, I'm changing the configuration. I'm not changing the code. I'm not redeploying my application, and not the server has been restarted. So when I do try it out, so let's see what's the output here. So we see here services under maintenance. So this is how you can do implement configurability. And configurability was implemented just by adding the dependency about MP configuration. So MicroProfile provide this feature. We just added the annotation and this file. So only thing is we updated the configuration, and if we change it to false, we were just updating this variable, and this variable is used in our business logic, right, to either share this method, and if it is false, then it will be executing the method as normal. So now I have changed it back to true. Now let me try again. So you see the list of products. So this is about the configurability of microservice. I'll take some short break and I'll come back. So till now we have learned a lot of features. We have learned about how to connect to a database, how to implement a microservice using the best practice of componentizing it into different layers. For example, we have the entity layer, we have the repository layer, we have the service layer, and the resource layer. Entity is the domain model. Repository is something that deals with the database. Service is the layer which contains the business logic, and resource is the layer which contains the logic or which contains the technicalities of HTTP request or REST protocol. And now next stages is we have to implement health checks. We have to implement matrices. We'll also look into OpenAPI in more detail. So I'll take a short break and we'll come back in 5 minutes. Come back. We looked into the Swagger or OpenAPI, and now let's get into more details about it. Let's deep dive into what all features it has. So let me open my notes. Okay, so yes, the documentation is based on this specification, which is OpenAPI specification. It was earlier known as Swagger specification because that was the name of the company. Now it is an open standard. This is a technical specification for documenting REST APIs. It describes and publishes the APIs in a format which could be consumed by various tools. So the UI which I showed was based on the YAML, and YAML could be consumed by various other tools, be it some third-party documentation tools or SDKs or some testing tools. So it's a community-driven initiative. Specification is used by many large organizations, which is like Google, Microsoft, and Amazon. And then we have here we have the MicroProfile and Jakarta RESTful web services, which are using these standards. Now, what's being used by MicroProfile open specification is it's using the standard version 3.1. So it has following features. One is the document generation, client SDK generation. So you can generate the clients in various languages because REST is agnostic. What you call is the language agnostic. It could be consumed by any programming language. It could be used for API testing. It could be used for API mocking. Now, to generate open API documentation, we need a dependency, which is MicroProfile OpenAPI 4.1. In our code, we would have this dependency, or we would have the entire MicroProfile dependency defined. So in our code, if we go, we have the pom.xml where we have the dependencies. So we have this entire MicroProfile 7.1 available. So that's why we don't have to explicitly say OpenAPI. But if you just want to use OpenAPI, you can use that particular dependency. Same you can use with Gradle as well. And as I already shared, that these are the annotations which we have to use to document our APIs. And then you have this URL where you will see the YAML. So we showed this YAML, and then there will be a Swagger UI which will also be available for you. Swagger UI, and there are various annotations which we can use. We can put the contact, we can put the license, we can put operation, API responses, request body, schema, parameters, tag, components. So there are a lot of tags which are useful for documenting the APIs. Now there are few new features. So with OpenAPI 4.1, we have several new features which are improvements over the previous version. One is the support for JSON schema 2012. This is one improvement. Another improvement is nullable handling improvement and enhanced schema composition. So these are some of the improvements which we have. And we have the support for Java records. So these are the improvements, because Java record is a new feature which has come after Java 14. In 14, it was an incubation feature, and it was finalized in Java 16. So that is supported. So you can annotate Java records, and that's the new update. So basically there are minor changes, and overall, no, there's not too much of difference, except some JSON schema changes are there, null handling, and there are two new methods which are added, which is extensible interface. Okay, so this is to extend Swagger. So as such, not too much of interest to the developers. It is for interest to tool vendors who want to build some toolings around Swagger specification. And then there is some improvements for using this with async methods. So if you have some webhooks or async operations, then there are some improvements around that. We'll cover that. We will be covering reactive APIs, reactive messaging, and async in next chapters. And in that, we will cover how to implement Swagger, and we will see how Swagger can be updated for that. So optional fields as null label. So there's better handling of optional fields. And with this is the description for optional field. You have the type string and null, both available. And then there are security schemas. So once we will implement the JWT authentication, so in case your APIs require authentication, then you can implement authentication into your Swagger as well by using security schemes. And with security schemes, now you can provide a token mechanism, or you can provide username password mechanism, where developer or whoever is testing the API using Swagger UI, he needs to enter the token or username password to access the method. And you can test the authentication protocol and security aspects of your APIs using these annotations. So this is about security schemes in OpenAPI documentation. So that's all in the Swagger OpenAPI documentation. So this is the latest enhancements in MicroProfile OpenAPI 4.1. So with this, I will close this part of our hands-on tutorial. I'll soon update about the next session, and which would be later today in few hours, where we will be covering more aspects about microservices, starting from health checks, matrices, then fault tolerance. There are a lot of things to be covered. I'm taking a break, lunch break for my time, and then in few hours I will start another stream where we will be building upon from where we left. We will enhance our product microservice, we'll add the payment microservice, we'll add inventory, shopping cart, and other services, and we will build REST clients as well, so that you will get a good understanding of all aspects of microservices. And then we will start using Docker containers and Kubernetes to deploy these microservices. So right now, let's take break and we'll start a new stream. So watch out my channel. If you haven't subscribed, subscribe to this channel and click the bell notification, and I will in few hours start the session again. I will announce it in few minutes, and then once the live stream happens, you can join again and continue. And in the meantime, you can watch the previous live streams so that you are up to date and all prepared for next concepts which we'll be covering. Thank you, and for any queries, feel free to post it in the chat. See you. So bye for now. Thank you.